Today we're talking about counting problems in math contests. There are really only two approaches to solving these: abstraction or brute force. Abstraction requires finding patterns, running formulas. Brute force just requires calculations. Most problems use both, but it's useful to recognize which way the problem leans. That way you can get the answer in the quickest way possible. So here are some tips to identify them. Brute force problems often have very few elements, very specific conditions, and feel like constraint puzzles. Abstraction problems often have huge answer spaces, very clean rules, and link themselves neatly to formulas. So question 1, 2020 KD question 23. Problem is on the screen. Pause and try and solve it. So if you tried it, you'll notice that this one leans to brute force. So some telling signs are there are only 4 unique elements. It's at least one of each for the next ordering conditions. It's very complex, but only on a surface level. It's not conceptually deep. You just worry about placing things carefully and avoiding violations. It's the kind of question that wants you to suffer. So, solution. You keep your work neat and systematic. You start with a general layout and then narrow it down. You place the least restricted numbers first, and then you move on to the more restricted ones. For example, you start with case 1. It might be 1, 2. Case 2 is 1, 1, 2. And you keep moving on. Work through all possible placements until you're complete. It's very important to not overthink it. Question 2 is the 2017 KD question 24. Problem is on the screen. Try to solve it. Let S of xyz be the number of ways to reach the state where x has moved x amount of times, y has moved y amount of times, and z amount of times. Now we always have z is greater than or equal to y, which is greater than or equal to x. So when you try to start doing casework on this question, start making calculations, you realize that after each step it explodes in complexity. So one way to organize your counting is with tables. So you break this 3D problem because it has x, y, and z, 3 variables, into 3 2D tables. So once you start fitting in the tables where it might be the x-axis denotes the amount of moves by x, and y-axis the amount of moves of y. Once you start fitting out these tables, you realize that S of xyz equals S of x minus 1 yz plus S of x y minus 1 z plus S of x y z minus 1. So this works because the last move must be x, y, or z. So we just sum the possibilities from each one. Invalid terms count as 0 and add a total of 0 possibilities to the total. Okay, last question of the day is the 2016 KD question 25. So this question is abstraction leaning. So by reading the question, by the setup, you can guess that the answers amount over 1000. So there are only 2 unique elements, and also it's the last question of a contest. So all these signs tell that this question is abstraction. So now let's go over the setup. So the rules are no repeated letters in a row, no 2 vowels in a row. Vowels are A, E, consonants are B, C, D. So let V sub n be the number of n letter words starting with a vowel, and let C sub n be the number of n letter words starting with a consonant. So we're going to try to build a relationship and a recursion with these terms. What is V sub n plus 1? Okay, well, our n letter word starting with a vowel is an n minus 1 letter word starting with a consonant plus a vowel in the front. And since there are only 2 vowels, V sub n plus 1 equals 2 C sub n. So we can extend this kind of thinking onto the consonant. So what is C sub n plus 1? So the first letter is a consonant. So how can we continue from that? So it can either be 2 of the 3 other consonants, because there are no 2 letters in a row, or it can be a vowel, and there are only 2 vowels. So C sub n plus 1 is equal to 2 C sub n plus 3 V sub n. So where do the 2 and 3 come from? Well, the 2 on the consonant stands for the number of other consonants, so 2 of the 3. And the 3 in front of the vowel stands for the number of consonants that could be before the vowel. So now how do we get the answer? So we start with n equals 1. So V sub 1 equals 2 because there are 2 vowels. C sub 1 equals 3. And then you build a table until you reach n equals 10. And then the answer is V sub 10.